It is found that when some particular types of substances are added to water and dissolved, their molecules are split into negative and positive ions. This process of splitting up molecules of a substance into positive and negative ions when it is dissolved in water is known as ionization. Now we will discuss about ionization process in detail. To understand the process, we will consider the structure of sodium chlorine, that is sodium chloride. Sodium chloride is the common salt we use in our day-to-day life. The atomic number of sodium and chlorine are 11 and 17 respectively. That means sodium or sodium atom has 11 number of electrons and chlorine or chlorine atom has 17 number of atoms in their orbits. Sodium atom has only one single electron in its outermost or valency orbit, whereas chlorine contains 7 electrons in its outermost orbit. But we know that for stability, atoms generally require 8 electrons in its outermost orbit. So, both of the shown atoms are chemically active. When these atoms are brought together, sodium atom loses its outermost electron and becomes positively charged, and chlorine atom gains one electron and becomes negatively charged. So both atoms acquire 8 electrons in their outermost orbit by exchanging these electrons. As the sodium atom is positively charged and chlorine atom is negatively charged, due to electrostatic force acting between them, they will come together and make one sodium chlorine or sodium chloride molecule. Now, according to Coulomb's law, the electrostatic force acting between two opposite charges is expressed as Q1 into Q2 divided by 4 pi epsilon 0 epsilon r into d square, where epsilon r is the relative permittivity of the medium. So it is clear that electrostatic force between two charges is inversely proportional to the relative permittivity of the medium in which the charges are placed. The ionization process can easily be explained by relative permittivity of the medium. The relative permittivity of air is nearly 1 and the relative permittivity of water at 20 degrees Celsius is 80. So in the water, the electrostatic force acting between sodium and chlorine in sodium chlorine molecule is 80 times smaller than that in the air. The electrostatic force between sodium and chlorine becomes so small that it becomes difficult to hold the sodium and chlorine together in water. That is why whenever sodium chlorine, that is sodium chloride, is dissolved in water, its molecules split into positive sodium ion and negative chlorine ion at room temperature. Thank you.